Welcome to Physics Can Be Fun. This is the second part of this question. Let's explain what we have here. We have a boy, 50 kilogram boy. He's traveling at 2 meters per second. He's on a little flat slope on a skateboard. Then he's going to go down the slope, travel for 10 meters, hit a ramp, go up for 10 meters, and he's going to try and jump over his brave friends who are lying there on the ground. And if he exceeds 20 meters per second, he's going to, let's say, get over his friends. Now, we calculated that without friction, his velocity at the end would be 22 meters per second, so he would be able to jump his friends. But now we're going to introduce friction to this type of problem. Now, last time, we calculated that the boy's total mechanical energy at the start, E total at the start, was 14800 joules. So we worked it out using these two formulae. His potential energy was his mass times g, 9,8, times his height. His height was 30 meters. And his kinetic energy was half mv squared, which was half his mass, which was 50, times v squared, and his velocity was 2. Adding the two together, we found his total energy was 14,800 joules. Now, we're going to show you what you do when we have a frictional force. So let's say we have friction. Force due to friction is going to be introduced, and let's say it's going to be 10 newtons. So how would we perhaps measure that? We get a spring balance and we pull the boy on his skateboard just along the flat road, and let's suppose it comes to 10 newtons just to keep him moving. So let's suppose all the way along the path he's got a frictional force equal to 10 newtons. So why don't we work out how much work it will take him to, due to friction, to pull him all the way along the slope. Let's use this formula for work. Work is equal to force times distance or displacement times cos theta. Now, cos theta is calculated as follows. If you have his displacement, which is that direction, friction is always going to be opposite to his displacement. So this is his delta x. That is going to be his frictional force. And so we measure theta as the angle between his direction of displacement and the direction which friction acts, which is exactly at 180 degrees. So do you understand that frictional force is 180 degrees to his displacement? So therefore we're going to get cos theta as cos 180 degrees. In other words, the angle between his displacement, which is down the slope, and his friction, which is up the slope. So what did we say the frictional force was? It was equal to 10. Now, what is his displacement? Well, let's just add it up. He goes 5, then he goes 50, then he goes 10, and then he goes 10, and the friction is the same all the way along that. So let's say his total displacement is going to be 5 plus 50, that's 55, plus 10, that's 65, plus 10, 75 meters. 75 meters. And I would explain to the examiner that how I worked it out. It's going to be 5 meters at the top of the slope, plus 50, plus 10, plus 10. And that comes to 75 meters for his total displacement. Right, so let's work out the work done in getting to move against friction. So that is 10 times 75 times cos 180. That comes to minus 750. Minus 750 joules. What does the minus denote? Isn't work a scalar? Yes, but this minus means energy lost due to non-conservative force of friction. So we're going to add this minus quantity to that amount there to find out what energy we end up with. So if we start with that, so the energy at the start is equal to 14800 minus 750, and the answer comes to at the end we are left with 14050 joules of energy. 14050 joules of energy at the end. So, friction has subtracted 750 joules of energy from our starting total mechanical energy. Now, at the end of the ramp, because of the height, we calculated in the previous problem, we had 2450 joules that went back into mechanical potential energy to go up the slope using mgh. So what are we going to do? We're going to say loss due to EP of the ramp is going to be equal to 2450. So we're going to subtract that from this here, minus 2450, and that means that the total amount of energy that is kinetic energy at the bottom of the slope at the top of the ramp is going to be EK at the final is going to be equal to 11600 joules. Right? So from our starting energy, we subtracted friction, we subtracted the remaining potential energy, and here's our final EK. And what's the formula for EK? That is also equal to half mv squared, which is equal to a half times 50 times v squared. So let's find and solve for v. So we're going to multiply both sides by 2. We're a bit short of space here. We're going to multiply both sides by 2 and divide both sides by 50, or in fact this comes to half of 50 is 25, so we're going to divide both sides by 25. That will fit in easier. So 11600 divided by 25 gives us 464 v squared is equal to 464. We're going to find the square root of both sides. Therefore, v, the square root of v squared is v. The square root of 464 is 21,54 meters per second, and it is greater than 20, so the skateboarder will still, even with friction, be able to jump over his friend. So here we have a skateboarder that knows his science well. He's worked out, would he be able to jump over the skateboard, over his friends, and even with friction he will be able to get enough velocity at the end to jump over his friends. So in summary, what did we do? In our previous problem, we'd worked out the total energy. In this problem, we subtracted his frictional, the loss of energy due to non-conservative force of friction, and that loss of energy came to, using, where's our formula here? We found that the loss of energy was minus 750. So we subtracted that from the starting energy, and that came to this amount. And from this amount, we then subtracted the little bit of potential energy, which was that amount. And we found that our final energy was 11600. All of that energy was kinetic energy, so all we had to do now was find the final velocity using the formula that this energy is equal to half mv squared, so therefore v came to 21,5 meters per second at the end. So that happened to be fast enough to jump over his friends. So again, working out the actual loss due to friction, force times displacement times cos theta, where theta is the angle between his movement and friction, which is always 180, and that just gives us a negative value denoting energy lost.